In lesson 6.5, we're going to look at two more ways to prove that triangles are similar to one another. First is we're going to use a side-side-side similarity theorem. What it says is that if corresponding side lengths of two triangles are proportional, then the triangles are going to be similar. So in this case, if AB is to RS as BC is to ST and CA is to TR, then triangle ABC is similar to triangle RST. So if we want to determine if these are similar or not, what we need to do is take triangle ABC and see if the sides are proportional with each of these. I'll start with looking at ABC and DEF. Triangle ABC and triangle DEF by finding the ratios of the corresponding parts. Now notice I have all of the sides there. So what I'm going to do is I'm going to compare the shortest two sides, AB and DE. That gives 8/6, which is a ratio of 4:3. Then I'll go with the longest sides. That's going to give me 16/12, so it's also as 4:3. And then the remaining side is 12/9, which is also 4:3. So if you look up there and see, what I did is I matched the shortest sides, the longest sides, and then the middle or remaining sides. Since all of them have ratios of 4:3, then the two triangles are are similar, and I can write my similarity statement. Now let's compare ABC and JHG. If I want to compare ABC to GHJ, then what I'll do is, once again, the shorter side, 8/8 is 1. The longest side, 16/16 is 1. But we can see the remaining side gives us 12/10, which is 6/5, which is not equal to 1. So those are not similar. So you need to always check, make sure you're pairing shortest side with the shortest side, middle with middle, and long with long. What value of X would make ABC similar to DEF? Well, if I match up AB and DE, I'm going to have 4:12. And then I could match up the BC and the EF. So I would have 4:12 is X minus 1 is to 18. Once again, we just take our cross product, we use our distributive property, and then we solve that equation to get that X is 7. Now, if I want to make sure that that's going to make them proportional, I'll plug in, find out that BC is 6, and check proportionality there, and it is. But I also need to plug in into that 3 times X plus 1, which is 24. And plug those numbers in, and I get that they are also proportional. So when X is 7, the triangles are similar by side-side-side similarity. Which of these three triangles are similar? Write a similarity statement. Now, you know that you should pause the video now and give this a try, and then come back and watch the way that I do it. Number 1, we find out that MLN is similar to ZYX, but neither of those are similar to RST. Now, how did we do that? Well, we started with our proportions and to see whether or not they had the same ratio. If I look at RST, my shortest side is 24. My shortest side of this one is 20. 4 going to both of those, so that reduces down to 6/5. If I take my next shortest side, which is 30, and my next shortest side here, which is 24, 6 will go into that, but that reduces to 5/4, so no, that one doesn't work. If I did the other two, I would get the same thing, but in these two, my shorter 20 to my shorter 30 is 2/3. My 24 compared to 36 is also 2/3, and my 26 compared to 39 is also 2/3. So since we have the same ratio, these two are similar. The shortest side of this triangle is similar shortest side of a triangle similar to this one is 12 units, so how long is the other sides? So I will get my ratio by saying the shortest side of the similar one to this one is 12 over 24, or 1/2. So I will use 1/2 is equal to what over 30, and find out that x is 15, and 1/2 is equal to what over 33, and find out that x is 16.5. So the answers are 15 and 16.5. We also have another theorem that says that if we know that a corresponding angle, one pair of corresponding angles are congruent, then if we can also show that the sides that include those angles are proportional, then we know that the two are similar. So we have a side angle side similarity. Now notice you cannot use this third side. It must be the two sides that include angle x and angle m. So I have to use xz with pm. I have to use xy with mn. This says that we're building a lean-to shelter from a tree branch as shown. Can you construct the right end so it's similar to the left using the angle and lengths shown in the diagram? Well, we can clearly see here that 53 is marked congruent with 53, so we have our angles. So we automatically know that A is congruent to F. So now we need the included sides. If I look at AB and FG, I have 9 to 6, which is 3 to 2. So I'll look at AC and FH, I have 15 to 10, which is also 3 to 2. So yes, by side angle side similarity, we can do that. The triangle similarity postulates and theorems, a quick review. We've done 3 of them now. We did the angle similarity. We did the side similarity, where the ratios of the 3 sides are all equal or they're proportional. And then we did the side angle side. But remember, it must be the 2 sides that include the corresponding angles. What method would I use to show that these triangles are similar? Well, what I would do is notice first, look here to see what I have. I would have 2 sides. I don't have any information about the third side, but I do have an angle here. So what I can do is find the ratios of the corresponding sides. Now remember, I'm going to do the short to the short and the long to the long, and I see that they're both 3/5, and I also have those 2 angles congruent by vertical angle theorem, and therefore we know we have side angle side similarity. In this particular case, explain how you would show it. Remember, you should pause and work this right now, but when you come back, you should find that R is congruent to N because they are both 90-degree angles, and if we set up the proportions, we get 4/3 for both of them. So yes, side angle side similarity. We have one more guided practice here. We want to show that the indicated triangles are similar when we look at XZW. XZW, we're looking at this small right triangle here, and then YZX is this other triangle over here. So we need to see how we can do it. We can do this one actually either way. We have all the sides of all 3 triangles, but we also have at least one angle for both of the triangles. So we can do the similarity statement either by side or by side angle side. Let's do the side side. If I match these up, my WZ is 16, my XZ is what corresponds to WZ, and that is 12, and 16 over 12 becomes 4/3. And if I match my middle length to the middle and the short, long to the long, short to the short, middle to the middle, I come out with 4/3 for all 3. So I have side. Since I have the right angles, I could use side angle side.